All right, everyone. So welcome to week 2 of the DVX online training. Today, we're going to be going through replication and some basic failover scenarios with DVX. So last week, we talked about snapshotting and protection groups and some kind of thoughts around how you should build your protection groups and your backups. And I felt like the next logical step would be to actually talk about how do we replicate those to another system, and then how to do some basic failover using those protection groups. Before we get too far into this, I got a couple questions via email last week, and I kind of wanted to address those now, just so you guys have the benefit of everybody getting to learn. The first question was, how do I set up the email alerts in the data node? So as I mentioned, it's through the CLI for all of the protection groups. So if you want to set those up, the way you need to do that is you come into your Datrium, you click Configure DVX, you find your email settings, and you configure your SMTP. So whether you're using an on-prem server or a relay of some kind, or just going straight to Office 365 or G Suite, you configure your email recipients. And once you've got all that, this is your normal alerting email. But the next thing that they were asking about is, okay, how do I actually configure the protection group alerts? And to do that, what we're going to do is we're going to log into the data node via SSH. And once we're logged into the data node, I'm going to do protection email recipients, and I'm going to do show just to see what the current state is. I know that the current state is disabled, but
hey Cameron,
yep.
I'm not sure if it's just me, but you're not sharing anything.
Thank you, Jonathan. Hold on one moment. Now I'm sharing. Oh, all right. It's noon and I haven't had enough coffee. So now that we're sharing, you guys should be able to see this. So we log into the data node, just the standard IP, or the standard management floating IP. We do protection email recipients show. Right now, this data node is disabled. So I would do protection email recipients enable and hit enter. And this will now enable all protection groups to send email to every email address that's listed in my configured DVX here. Okay, so kind of upsides, downsides. Upsides, you're now going to get nightly reports or hourly reports whenever it is that you're doing protection group snapshots. You're going to get emails when those happen. So for those of you who are dealing with SOC 2 Type 2, for those of you who have just internal requirements for this, fantastic. You're able to get that covered. The downside to this is that this is an all on or all off setting for the entire cluster. So I don't have the ability in this to say I only care about like my tier 1, tier 2 apps. I really don't care about my other protection groups. The best recommendation I can make for that is to set up either an email alias or a shared mailbox. Have all of your Datrium alerts go to that alias or that shared mailbox, and then basically just create SMTP rules either in Exchange or in your G Suite to funnel those emails out to where you want them to go. So same thing, if you have like an IT alerts email and then you've got maybe a backup alerts email. So if you've got two separate groups internally that handle the two separate functions, unfortunately, those are not things that we can separate out right now, and you would need to do via SMTP rules. So not terribly difficult, a little bit annoying, but it is an all on, all off per cluster. In my case here, I have two DVXs. So I have a DR site as well that I would need to I have a DR site as well, and I would need to go enable this over at my DR site if I want alerts coming out of that DVX. So pretty simple to do, but it does need to be done at the CLI. There is not a way to do this currently through the GUI. So that was the first question I got. The second question I got was regarding the snapshots, and I made a comment about the fact that I'm working on a way to actually do some more monitoring out of the change rates of the snapshots. I was hoping I would have that done and written up and sent out to you guys, and I've actually run into a couple roadblocks in how I'm creating this. So this is like a call to the community. I'll show you guys what I'm doing right now, and if you have any ideas on how to make this better, because now that I'm a sales guy and not actually doing admin work every day, I've lost a bunch of my skills. But basically, to monitor the growth of the protection groups on your own, the first thing that you got to do is in the CLI, you need to know the actual ID of the protection group. So if I do protection groups show, I'm going to get a list of all the groups, and then I get their actual ID. In this case, I want CTJ all VMs because I want to monitor that for growth over time. I'm going to go ahead and I'm going to grab that ID. And if I do protection groups snapshots show, and then I give it the ID of the group, now it'll come out and it'll actually break this out and it'll show me everything related to that PG. So not just the overall unique and total, but it'll show me the actual snaps that are in the PG, and it'll show me their unique size and total size as well. So that's great, except this is all done for the CLI, and I need a way to export this. So kind of where I'm sitting with that right now is if I go to PowerShell and I were to run the same command, first issue that I'm running into, right? So if I do an SSH get, essentially to SSH run the command and then have it output here, the first issue that I'm running into is that I've got to pass credentials every time. Unfortunately, and I worked with support and I worked with engineering on this to try to find out if there's a way to do it. As it stands, we don't have a way to export SSH keys out of the data node. If I could have done that, this would not be a problem, but that's kind of my first pitfall, is that every time I go do this get, I've got to actually manually log in and, I've got to actually manually log in and do that. So I'm going to manually log in, and great, now I get the list. The second problem with this list is that this is not actually formatted in any kind of normal way. So these are not true columns. The columns are not fixed length. They are not like tab delimited. They are literally just presented as you see this. So trying to take this output and do any kind of like get object in PowerShell or any other type of language I've worked with so far, this doesn't work because this looks like just one big string. So the way around that is I can do this in a JSON output, and that works, right? Because now I have my individual snaps and I've got their information, and this is all nice and pretty. So if I output to JSON and I save these to individual files, and then I read them back in and basically do a SQL query where it's like, hey, go read the JSON file, pull these lines out of it, and then dump them into this table in SQL, that's working awesome. The problem is I don't have a good way to automate that workflow, and I'm trying to automate this whole workflow without using paid tools. And the whole reason I want to do that is I want to make sure that anybody on this call, regardless of who you are, would be able to use this. I know for the people who have Logic Monitor on this call, I know exactly how I would have done this in Logic Monitor through a collector, and it would have been really super simple. But I don't want to tell all of you to go buy a specific reporting tool just because it happens to work for the project that I want to do. So that's kind of some wrap up from last week, and let's go ahead and jump into this week's content. So The first thing that we need to talk about is how do we actually do replication, right? We've talked a lot about how Datrium does a globally deduped replication namespace. We talk about how we only move the change data. It's all very smart on how it does that, but what's the actual underlying technology? So the actual underlying technology is this. We do our snapshot like normal, right? So we talked about that last week, and a snapshot is basically we copy the original snap, we look for the differences, and the differences are what gets saved in the snap store, okay? Now, when we replicate that secondary snapshot to site 2, what we're doing is we're first pulling out the diff blocks, and we're saying, okay, these are the blocks that have changed, and this is the metadata that we need to update. So we send that to the secondary site, and we say, okay, here's your updated metadata. Then what we do is we copy the snap at the secondary site. So we basically say, hey, we're going to copy snap 1, we're going to make it snap 2, and then we're going to go ahead and we're going to know that we've got these 2 blocks that have changed. So we know that we're about to receive those diff blocks. But when we send, what we're doing is we're actually checking the dedupe pool at the secondary site. So if those diff blocks already exist at the secondary site, we skip this step entirely. If they don't, then we send the actual block, okay? So this is how we are able to do seed of snapshots. This is how, if you're doing application layer replication, so if you've got like a SQL always on availability group and you're doing SQL level replication, or you're doing exchange DAG replication or DFSR or whatever, how you can snap and replicate a file server or an exchange server or something like that. And the replication takes like 30 seconds because you've already got the data at the secondary site. We're just updating our metadata. But at the same point, if you don't have that data at the secondary site, we're only sending the data that doesn't exist, okay? And then once it's all done, we're doing the validation. So we're doing the compare between the 2 sites to say, do all of my snaps line up? Do all the blocks line up? Is this all good, right? We also mentioned last week that on the 201st snapshot in a protection group, we do this validation at the very beginning. So we actually do a full compare of the entire snapshot chain at the very beginning before we send data. And we do that because we feel that, you know, once the data set starts to get larger, we want to be very, very sure that all the blocks are there, that everything is intact, that all the snapshots are good as the chains start to get larger. Okay, so we do this compare on every operation, but we do it in a more lengthy way the more snapshots that you have. And again, that magic number is 200, okay? When we talk about going site to site, one of the things that you're noticing here is that we're not going directly between the data nodes. We're actually going between compute nodes as the replica proxies. So the data nodes do send some data, and we're going to talk about that on the next slide, but really all of your replication traffic is happening through the compute nodes. And the reason that it's happening through the compute nodes is that you've got your most active data in Flash in the compute node. So why would I do a data node read to go get that data when I've already got the block in the host Flash and I could just send it out of host Flash and it would be faster? And then similarly, why would I only dedicate one host or one controller on a data node to do replication when if I've got 4, 6, 8, 10 hosts in my cluster, I could use every host and I could speed up the replica, not to mention I could provide more replica bandwidth, okay? So as we go site to site, we scale out the replication as we add more hosts, and we don't need a balanced number. So if you just have a single host at a single site, that's totally fine. Just know that if you start having replication issues, that adding a second host will actually solve those replication issues in a lot of cases. When we go out to the cloud, it's the same thing, right? We can replicate from the host into Cloud DVX, and that's why Cloud DVX needs that EC2 instance sitting on top of it. It's not just an S3 bucket that's underneath. There's actually the EC2 instance that does all the same DVX stack as on-prem that lives in the cloud so that we can get that same benefit. And when we have multiple cloud DVXs that are taking replicas, we get that same multi-host replication benefit for ingress and egress data as we do replica. Again, it's all globally deduped. So as we replicate site to site, if you have kind of that central site, maybe that's your cloud DVX, where you've got multiple sites replicating into a single cloud DVX bucket, what you'll probably start to notice is that your cloud DVX is getting better deduplication than your two individual sites. And that's something we totally expect. Another kind of cool thing about this is that it gives you that ability to hydrate a remote site with a non-Datrium backup. And so a really good use case that I had for that was I had a customer that bought 2 sites worth of DVX. They told us to go ahead and ship the data nodes to their 2 separate data centers. And we shipped a data node to the secondary data center, and they realized, oh crap, we got 100 terabytes to replicate, and we've got like a 15 meg pipe between these 2 data centers. How are we ever going to actually be able to replicate this? And so what we did was we restored all of their Veeam backups. So we took their very latest Veeam backup, we restored it into the data node. So almost like doing just a regular VM restore to populate a new SAN, as if your old SAN crashed. And then when we did the initial replication from the primary site to the secondary site, even though the snaps didn't exist at the secondary site, because the data existed in the global dedupe pool, when we did all those diff compares, we were like, oh yeah, I don't have this in the snapshot, but I do have that block. And so I'm just going to reference that block. And so we were able to move just the data from the time that that last Veeam backup was taken to the time that they got this all set up. And we were actually able to get them replicating, whereas we were originally thinking, before we even tried that, we were originally thinking that, oh shoot, we're going to have to, unrack a data node and ship it cross country and seed it and then ship it back, and it was going to be a whole problem. But being able to hydrate from essentially a non-Datrium backup was really cool, and again just speaks volumes to the value of that global dedupe pool as you're trying to get things replicated. So last thing I want to talk about before we get into some demo is what these networks actually look like. So the snapshot metadata goes data node to data node. We send that out over the management network, and it goes site to site, no problem, right? Not a lot of data is traversing that because it's literally just updating the metadata. The actual replication, so the actual movement of the data, comes out of your hosts. By default, we use whatever the first routable network is. And usually that's your management VM kernel port. So whatever your ESX management interface is usually the network that we use to do site-to-site replication. I'm going to show you in a second how you can change that. So if you're someone who has maybe a dedicated link between sites that you use for replication, or maybe you've got like 2 1 gig pipes between your data center and your like your data center and your DR site, and one pipe you use for regular traffic, the other pipe you use for backup traffic. I can show you how to set that up. So we'll talk about that in a second. But again, you're noticing that I've got a dissimilar number of hosts at these 2 sites. My data is coming out of the flash cache in the host as much as I can, and any data that's not in the flash cache gets hydrated from the data node into flash cache and then sent out the same as a traditional cache miss would if we were just reading the data node, or just reading the data off the data node. When we write at the secondary site, the ingress path is the same thing as a normal write. So you're doing your dedupe, your compress, your encrypt, and your erasure code the same as you normally would. So that's why not only do we need a host at that secondary site, we can't just put a data node there, but that host does need to have some local flash in it because we're doing the same write path at the DR site as we do on the prod site. You'll also notice that this says LAN WAN. So almost every customer ever replicates directly over some sort of VPN, some sort of site-to-site connection, dark fiber, whatever you got. They do it on the LAN, and that's the way you should do it. However, Cloud DVX sits directly on the WAN. right? It's AWS, it sits directly on the public internet. And so we've set this up that you can replicate directly over public internet and use our replication encryption to secure that tunnel for you instead of having to go over VPN or anything like that. So again, that's how with the AWS stuff, we're able to do replication without needing any kind of VPN or direct path or anything like that. Okay. So now that we understand the replication topologies, let's actually talk about getting these set up site to site, and then let's look at what it looks like to actually fail over a VM. So I'm going to go ahead and I'm going to pull up my DVX at my prod site. And the first thing that I need to do when I'm setting up replication, either existing DVX or new DVX, whatever you're doing, the first thing that we do is we need to enable encryption, okay? So we need to enable the site-to-site encryption for our replication. Now, why do we need to do this? Because when we replicate, we don't share our encryption keys site-to-site. So what we're actually doing is we're decrypting and then sending data in plain text to the secondary site, so that when the data lands at the secondary site, it re-encrypts with the secondary site's keys. So that's how, if you lose your primary site, your data at your secondary site is not encrypted with the primary site's keys, and now you're like, shoot, I can't use my backups because I can't talk to that site. They're all independent, and that's also what helps when you're talking about security, minimizing impact. So if somebody gets your decryption keys for one site, well, if you've got multiple sites and you've got data spread out, they've only got the keys for that site. They don't have the entire access to all of your backups, right? But if we enable the encryption tunnel, it's a TLS 1.2 tunnel that we create to go site to site. So whether you're going over the WAN or the LAN, we know that the data is always being sent in an encrypted tunnel. So this is the first step that we always want to do, is enable tunnel encryption. And then we need to go and we need to actually set up a secondary site. So that site can be either cloud or prem DVX, but all I need to do is come down to replica sites. I click add site. I'm going to give it the IP address of my data node at the other site, or FQDN if you want. I'm going to give it the admin password for that secondary site, and then I'm going to create a site label, and that's just a friendly name. So you can name it whatever you want. The other way to do it is a cloud DVX system. We're going to get, in a different module, we're going to get a lot deeper into cloud and what you're able to do with setting up cloud. But for right now, just know that if you needed to create a cloud DVX and cloud was already set up, all you would have to do is just say add cloud DVX. I can select the site that I want. So any of the North America AZs, so this is a North American-based firmware, so that's why we're focusing mostly on US-based AZs. You'll notice that GovCloud is one that we can set if that's what you want. And then I can select my instance size, give it a name, and click deploy, and it will deploy my cloud DVX. So now I have a replica site, but it's an asynchronous replication. So if I want to be able to replicate back, I'm going to need to go over to my secondary site. I'm going to need to go and do the exact same thing. So click on protection groups at the secondary site, enable encryption over here so that its outbound replications are encrypted, and then come down to remote sites, add my sites, and do the same configuration over here. Okay. The limitations on this, I can have 10 outbound sites and 10 inbound sites. So it's completely up to you how you want to build that topology, but a single DVX cluster can have 10 outbound replication members and then take replication from 10 inbound members. And they don't have to be the same, they can be whatever you want, but 10 is your limitation. Okay. Also, just so you know, those are tested limits, not hard limits. So if you have a valid use case that you need, 50, 100 sites replicating into your DVX, that's something you just need to let me know, and we can put in the RFE for that. The second thing is, what if I want to do any kind of throttling? So if I want to do that, all I got to do is I select my site, I click the little drop down here, and I'm going to click throttle. And I now have the ability to throttle either bandwidth or schedule or both, right? So I can do, unlimited bandwidth, but only during these times. I can do limited bandwidth all the time, or I can do limited bandwidth plus scheduling. It's completely up to you how you want to configure that. Again, these are per site throttles. So if you want unlimited out to your cloud DVX, but maybe limited to your DR DVX or vice versa, you can set all that up. But these are not throttles per protection group. So it's a throttle between the sites, but it's not a throttle per protection group. And we can see in the statuses down here, we can see whether or not we have a throttle. And then we can also see our current replication bandwidth to that site. I can also see on the under DVX system, if I go to DVX system and I go to the historical charts tab, I can see my total outbound replication bandwidth over time. So if I'm trying to troubleshoot a replication performance issue, I can troubleshoot it. I can troubleshoot it there. So the next thing that I would need to do is, great, I've added my secondary site, whether that's Cloud DVX or that's, maybe I bought another Datrium for another site and I've got it all set up now. So we need to actually start replicating. So the first thing that I'm going to do is I'm going to take an existing protection group and I'm going to come over to edit protection group schedule. And I'm going to go ahead and I'm going to select whatever replicas I want for that PG, right? So maybe I don't need my hourlies. Maybe I'm just sending my dailies and my weeklies. Maybe I don't need my dailies and weeklies because this is really just for business continuity and anything more than 4 hours is not useful to me. I can set this up however I want. The other thing that you're going to notice is that your DR site, again, has a different retention policy, and you can set those to be whatever makes the most sense for you. So if you want to match the policy that you have at the prod site, if you want less time, if you want more time, it's completely up to you. When I was at Altair, I set my replica site to have actually less retention than my prod site. And the reason that we did that was we wanted to have the minimum amount of gear at our DR site as possible. So we set all of the protection groups to make sure that we would have, enough data to recover from, even if the most, the last 2 points weren't useful, we'd still have enough useful points to be able to pull from. But I didn't want to hold my entire data set of DR. I just wanted to hold the data set that would actually be valuable in a business continuity event, so that I didn't have to have a like for like prod and DR site. Some other customers that I'm working with that are on this call, you guys have really long archive retention requirements, either for state government related stuff or just internal policy says you keep data for 5 or 7 years. And in those cases, having a DR site replication where it is holding that data at the DR site for 7 years, so that your prod site is able to just have the most critical data. You've got extra space at your prod site to do things like development and spin up test workloads and things like that. And the extra space at your DR site you're using for your retention. So it's kind of up to you how you build those. But if I don't do this next step, I have to wait for my next backup period. So in this case, that was an hourly backup that I was taking, and it's now 12:31. And if I want to replicate, if I want to start using this data at the secondary site, I either have to wait 30 minutes for it to snap and then do that initial replication, or I can come in and I can click on the protection group. I can find my latest snapshot. And if I don't have a snapshot that is within a time frame I like, I could always create a new snapshot. So I could just click the Take Snapshot button right here. But I have one here that's within a time frame that I think is pretty reasonable. And I'm going to click Replicate. So I'm going to select that snapshot and I'm going to click Replicate. And I'm going to select the DR DVX. And then I'm going to select how long I want to keep this for. So this is really, whoops, I'm going to go back to that. This is really important, okay? I learned this when I was first setting up Datrium, and I know there's been a few people on this call that have kind of learned this the hard way as well. When I first started setting up the snapshots at Altair for replication, I had just regular, retention set, and I thought I was good. They got in sync, and everything looked great. Well, the problem was before I shipped that data node out to my DR site, I powered it off to get it ready to pack up, and then ended up not shipping it for longer than I thought I would. So I was like, yeah, I'll power it back on, and I'll just go ahead and I'll do one last sync before we take it out of the rack and we pack it up and we ship it out there. Well, what I didn't think about was the fact that I had a bunch of hourly points and a bunch of daily points that were only being retained for a couple days. And so when I powered back on that data node, I had almost no data in it. And I essentially had to do a full resync of a bunch of the data that I had been seeding. And I'm glad that I found it before I shipped it. Otherwise, that would have been a really bad thing. We've had a couple customers that have done the same thing. They seed their data node, they box it up, they ship it, and then it gets to their DR site and they power it on, and their snapshots hit their expiration, and now they've got this data node that has almost no useful data. Now support has a way to get that back, and as long as we don't go all the way through garbage collection, there's some cool things we can do to save that, but it's better if you just prevent that from ever happening in the first place. And so that's why I usually like to set my first replicated snapshot for 1 year. So I'll tell it that I want to do 1 year, and then I replicate this snapshot to my DR site, and now this base data set will stay on that DVX for 1 year. So the idea there being that if I do send this Datrium, if I do send that DR DVX to another site, or we have any kind of lengthy replication issue, whatever it is, I at least have a base data set that will be there, and I'm not having to constantly replicate a full. And I've seen that as well, where basically a customer got out of sync, and they had to restart their replication. They had a bandwidth issue site to site. They got really out of sync for a couple weeks. They fixed the issue. Now we got to catch up on all the data. Well, it was essentially a full resync. And what was happening is basically the snapshot would land and then expire. And so the next snapshot that was then coming behind it was having to be a full. So instead of being a diff, it was a full. And they called me up and they're like, dude, it's almost like these replications are never finishing. Like, we just keep replicating data, and it's a ton of data every time. What's happening? And that's where we figured out, yeah, it's because basically your snapshots are taking so long to replicate that they land and then they expire, and then you've got to re-replicate the whole thing. And so by stopping that process, manually replicating a snapshot, putting a year retention period on it, and then re-enabling the schedule, that allowed us to get that customer caught up, and they haven't had any major replication issues since. The last kind of cool thing about when we talk about replicating site to site is that if I have let's say these top 4 snapshots here. So I've got my 30-minute ago, 2-hour ago, 3-hour ago, 4-hour ago. Let's say that I had lost connectivity between the 2 sites, and I have to I've gotten that connectivity back, and I need to replicate these 4 snapshots. Well, in most backups, right, in most backup software that you guys would use, or even SAN-based replication, you would have to start with snapshot 4, because that's the oldest child. So you need to start with 4. Once 4 replicates, then 3 replicates, then 2 replicates, then 1 replicates. Well, if I'm in a DR situation, and I need to recover at my secondary site, do you think I want snapshot 1 or do I want snapshot 4? Well, I want snapshot 1. It's the latest copy of my data. I don't want to go back to snapshot 4 unless I absolutely have to, but my backup software won't let me replicate snapshot 1 first. Datrium doesn't do that. Datrium replicates snapshot 1 first. And we do it for a couple reasons. The first is that we believe the largest amount of change data is going to be in the newest snapshot. So from wherever you were to your latest snapshot, that's going to be the most amount of change. If we replicate that one first and then replicate 2, 3, and 4, so if we work it backwards, we actually end up replicating less data, because the biggest change went first, and then beyond that, you're replicating less data. And secondarily, that finish is a lot faster because, again, you're replicating less data. So by doing it that way, not only do I have the most current copy of the data as the first inbound replication, but then the second thing is I have less subsequent replication, and I'm actually able to catch those up instead of constantly being a couple days behind. So just a cool thing is you think about if you do lose connectivity between sites for whatever reason, when you reestablish that connectivity and we automatically pick the replication schedule back up, we start with the newest snap and then we work our way back. So pretty cool stuff there. Okay, so now that I understand my replication bandwidth, my topologies a little bit, the last thing that I want to mention is if I've got a bunch of protection groups like we do here in our lab, if I've got a bunch of protection groups and they're all replicating to the same site, it's probably not the best idea for me to have all of my groups replicating at the top of the hour, or replicating the same 4 hours. Mostly just because everybody's got limited bandwidth, right? Even if I've got 10 hosts at each side and I could push 10 gigs of throughput from a host perspective, I'm limited on what my site-to-site bandwidth is. And I've got to share that not just with my replication, but I got to share that with everything else in my data center. And if I'm replicating out to the cloud, then I got to share my internet with all of my users as well, right? So one of the things that we've done in our lab here, and one of the things that we kind of recommend as being best practice, is that if you are going to have two sites that are replicating to each other, so maybe you've got two active sites, they both take snapshots hourly and they replicate them, site A should be at the top of the hour and site B should be at the bottom of the hour. So what you want to do, because we replicate as soon as we take that snapshot, what you would want to do at site B here is I'd want to edit the protection group and schedule. And instead of being hourly on the 00, I'd do it hourly on the 30. And then same thing on my dailies. I'd probably do site A at maybe midnight, and then I'm going to do site B at 1 a.m. And the idea is that you're not overlapping the replications, so you're not consuming all of your bandwidth, and you're not having to throttle, right? So I'm not having to throttle the two sites. I'm allowed to use the full pipe, and I'm not creating this in and outbound traffic jam. The other thing to think about is, again, because we are using the hosts for replication, if I've got a high I/O period in my data center, so maybe I do some sort of SQL reindexing job every day, and I just know that between 8 and 9 p.m. my SQL servers are just getting absolutely thrashed, and maybe that's not the best time to be doing replication. Maybe that's not the best time to be using those hosts to also do some replication. And maybe I just want to make sure that my protection groups and my inbound replications are not happening during those periods. So just things to think about, right? That because as soon as we snapshot, we immediately replicate. It's not like a traditional backup where you've usually got your backup jobs and then you've got a secondary job to do the replication, and you schedule those a little bit differently. These are happening all at the same time, so just be cognizant of that. If it's a backup job that's happening just to the local data store, yeah, no problem, right? If we're just protecting it locally, we're not replicating it, don't worry about it. But if we are replicating, just be aware of when you're replicating and how much change data that's creating, and maybe think about changing up your schedules. Okay. So now that I've got everything replicating, now that I've got stuff going site to site, and everything's good, maybe I'm in a situation now where I need to bring something up at my DR data center, whether it's a single VM or it's an entire protection group. Let's look at how we would do that. So I'm going to flip over to my DR DVX, and this is actually in a different vCenter. So this is a completely different vCenter, completely different DVX cluster from prod, different hosts, different everything. And let's say that I need to go ahead and bring up a VM over here. So the first thing that I'm going to do is I'm going to come into DVX, and I'm going to go to the VMs tab, and I'm going to find the VM that I want. And you're going to notice when we're in here, if I want to bring up, let's say CTJ, let's do DFS 02. Oops. So we'll notice that I've got DC02 here, but I don't see the DFS server that I want. Well, that's because I'm looking at the data store view. What I need to be looking at is the snap store view. Snap store view is showing me all the VMs that are available in all the backups. So even if it's not mounted in the data store, if it's an old VM that I've got a backup of, that we deleted out of the data store and we needed to recover, it would be in Snap Store. Or if it's a VM that's been replicated from another site, it just hasn't been recovered, again, it's going to be in Snap Store. So I'm going to change from data store to Snap Store view. There's my DFS box. So I got DFS1 and DFS2, and I want to restore DFS2. So I'm going to restore the VM. It's going to tell me which snapshot do I want to pull this from. So I've got a couple VMs I can do, or I got a couple options here. I could do my hourly from 2 days ago, or I've got 2 months ago. And if those don't work, I could always look at 01 here and find out what it's got. And I can find out that actually these have hourly snaps, and this one's from 44 minutes ago. So that's the one I want to use, because these are DFSR boxes, so they've got exactly the same data on them. I'm going to restore it into a data store. Something I usually like to do, and we're going to talk about this in the deeper dive on the DR that we're going to do next week when we talk more about an actual full data center failover. But what I like to do is I always like to create another data store for my recovered VMs, just so that I've got some delineation between what is a production VM and what's a recovered VM. In this case, I'm going to pull the DR data store. I'm going to tell it to recover, and we're going to see here that the VM is recovering itself. And as soon, yep, there it goes, it's done. And as soon as that's done, I'm going to come in here. I'm going to go to data store 1. Oops, I'm going to go to files, not VMs. I'm going to go to files. I'm going to find that, so that's right here. It's DFS1 box. And then I'm going to go ahead and I'm going to register the VM. And I'm going to put that into my personal VM. There we go, DFS. And then I'm going to select, of course, my hosts. And we're going to do just a regular VM registration, okay? For a single VM, that's not that bad. The only last thing that I'd have to do is, okay, now it's over here. I've got to come in here. I'm going to edit the VM settings, and I'm going to update my network, because my network from the prod site is not at the DR site. So I need to actually come in here, pick my DR network, hit OK. I'd power on this VM, and then I'd have to change the IP address to be something at my DR site, okay? For a single VM, that's not bad. And all of these steps can actually be automated through VRA. If you want an example of that, if you log into support.datrium.com and you go to the documentation tab and you select the Python SDK from the documentation tab, not only do we have our API, but we have some really cool examples of scripts that people have written in Python and then used vRealize automation and vRealize orchestration to do single-click actions where you could right-click on the cluster, you could tell it to recover a Datrium snapshot, and it would do these things for you. So not a ton of work. However, if I was in a DR situation where I had to recover all of my VMs and not just a single VM, then that's going to be a little bit different, and that's where control shift is going to come into play and would be something that you'd probably be more interested in. So if I need to recover an entire protection group, at my secondary site, first thing that I'm going to do is I'm going to come into replica groups. You'll notice I got two things here. I've got a live group and I've got a replica group. A replica group is an inbound group, and that's basically what it's telling me. I'm not taking any local snapshots of this. I'm just taking inbound replications from another site, and these are the protection groups that are associated with that. I could do a couple things with this. I could either promote this from a replica group to a live group, which is a step that we will need to do in a second. And then of course I can delete all the local snapshots that are associated with that group. But in this case, if I just want to take a replica group and I want to recover all the VMs that are associated with it, I would click it. I'm going to find the snapshot that's got all my VMs, and I'm going to tell it that I want to restore. And it's going to go ahead and it's going to restore every VM that's associated with this snapshot into DR data store 1, okay? Which in this particular case, it's only 2 VMs. So I could go in and I could recover these and it wouldn't be an issue. If you've got 35 VMs, you're going to be spending a lot of time registering individual VMs, changing their network settings, going through all that. So again, Control Shift, that's where that's going to come in. That's where that's going to help you. Once I've got all my VMs recovered, I want to start taking snapshots of those VMs. I want to back those VMs up while they're at my DR site. And so when I do that, all I got to do is come back here, select the group, click promote, and it's going to go ahead and it's going to promote from being an inbound replica group to taking all the settings, promoting it to start taking snapshots locally, and then reverse the replication topology back to the prod site so that when the prod site comes back online, or maybe if we just moved a workload from our prod to our DR data center, we can still send those replicas back to prod. Okay, so few manual steps here. If you're small, it's really not that bad. But if you're big, that's where Control Shift comes into play. So we'll take a look at what it would look like if I was replicating already. So if I was using protection groups, I was replicating already, and then I just bought Control Shift, and I want to now look at what that actually looks like. So we're going to go ahead. We're going to get the Control Shift interface up, and in this particular case, I can see that I've got my DR site, my prod site. I've got a Cloud DVX, and that Cloud DVX is actually hooked to a VMC SDDC. Not going to talk about this part today. We're going to talk about that later. But this is, again, what a pretty normal Control Shift interface looks like. So I'm going to go ahead and I'm going to create a new DR plan to go from prod to DR and specify the VMs that I want in that. I've got one built out already, so I'm going to grab it and we're just going to modify it. Edit this guy real quick. But it's a very, very, very simple setup. So all we're going to do is we're going to tell it, hey, I'm going to call it something. I'm going to give it a description. And I've got 3 options. I can do site to site, I can do site to cloud, or I can do site to question mark. Site to cloud and site to question mark, we'll talk about again in a deeper dive of Control Shift. Right now, we're focusing on just site to site. I can tell it what primary site I'm coming from. In this case, it's going to be the prod site, the failover site. And then I've got actually a couple other options here. I've got an option to say, hey, if the DR site doesn't have the latest snapshot, where else might have it? In this case, I could select Cloud DVX and I could say, hey, Cloud DVX might actually have a newer version of the data, so check there. And then I've got a test site. So if I have a site that is not DR that I want to use for testing, I can specify that here. Okay. Groups, this is going to be my protection groups that are going site to site. So again, this is why you need to have all of your protection groups built, and they need to be replicating before you come in and build this Control Shift plan. And I can also see the groups that are built but have no replicas between them. And so it's very easy to figure out, from these protection groups, whether you set them up correctly and whether or not the data is actually replicating. So I'm going to select my group. Data store mappings, pretty simple. And what you'll notice from all these other tabs is that I can have a different test mapping than my failover mapping. So if I have test resources that are in some sort of sandbox that I want different from my prod actual failover, I can specify my test mappings to be different than my prod so that when I click test, it obviously is different than prod. You can also mix and match that. So if you want to use a different data store for test, but you want to use the same networks, or vice versa, if you want to use the same data store for test and failover, but you want to use different networks, all of these are customizable on each tab. Okay, mapping vCenters, self-explanatory. Mapping the vCenter folders, self-explanatory. Compute resources, again, self-explanatory. Virtual networks. So this gives me that ability to say, hey, maybe if I'm not using NSX, if I'm not using virtual distributed switching that's spanning multiple sites, I can come in here and I can specify the source network and the destination network. So in my case, you can see CTJ private goes to CTJ DR, right? Again, if I wanted to use a different network for tests, so if my test all is going to go into a sandbox network of some kind, I could swap the test network mapping from the prod failover mapping, and I can bring up all my test resources in a sandbox. IP address mapping. So we have a couple different ways we can do this. One is to say, I don't want to do any IP address mapping. You're just going to bring it up with the same IPs. And again, if you're doing any kind of stretch LAN, that's what you would do. But if you've got different networks of the two sites, we can either build IP address by the network range. So the first 3 octets will change at the DR site. And then of course the gateway, the subnet mask, and the DNS servers. Or I can do one-to-one IP address mappings. So it's completely up to you kind of what you want to do at the two sites. So once I've got all those rules, the next thing that we have is a script VM. Script VM is useful for a lot of things, but nothing that we're going to talk about right now. So again, in our deeper dive of disaster recovery using Control Shift, I'll talk about scripts VMs and why you would want to use them. And then I've got my actual recovery steps here. So in this, you can see this is super simple. I'm telling it that I want to recover the protection group. So that's the first thing that I have to do, is I have to recover the entire protection group. Because what it's doing is it's basically saying, hey, at what point, like what snapshot are all these VMs recovering to? So that's my first step. Second step is I want to recover my DFS box, because that DFS box is got some witness shares for SQL. It's got some inbound EFT shares that SQL uses to pick up from. So I need my file server online first. So pretty simple. It's telling it, go ahead and recover this server and then power it on, okay? And then it's telling it to wait for the IP address to come online for 5 minutes. Now, I can do an IP address or I can do VMware tools. It's up to you. Personally, I like IP address, and I like it for 2 reasons. The first is that it means that the network is working. It means that all of my network settings at the secondary site are correct. We did the re-IP address of the VM correct. All the things are correct on the network, and all the services should come up and they should all be accessible. Some people prefer VMware tools. It's completely up to you what you like. I've just been burned too many times by SRM just rebooting a VM that is perfectly good, but just had a bad VMware tools package on it. And SRM thought that, hey, the VM, basically it hit my timeout and VMware tools didn't come online. So I'm just going to reboot the VM because I can't heartbeat it. IP address for me works a lot better. So it's up to you what you want to do. So I'm going to wait for that IP to come online. And as soon as it comes online, I'm going to recover and power on my SQL server. And then same thing, I'm going to wait for SQL and we're going to be done. And then I've got all of my alert triggers. So now, if I come in here and I were to say, I'm going to delete this VM. I'm going to delete from disk. So now, if I come back into Control Shift and I come back in here, and I'm going to edit one thing real quick because it's failing on IP addresses right now. That's the error that you're seeing, and I know that it's failing on IPs. So I'm just gonna pull that step out because we don't actually need the network for this to work. But if I refresh my continuous compliance check here, I should see all green check marks. One of the cool things about this continuous compliance checking is that we do this automatically every 30 minutes, and then we let you know if something's broken. So we're checking the RPO of the replication, we're checking the availability of the resources at the secondary site, and then we're also checking network at the secondary site to make sure that everything's good. So if this all comes back green, which it should, I would be able to then click test plan, and I can select the snapshot that I want to use. So if I don't want to use the most recent, I can go back in time. Again, super helpful for if you've been troubleshooting an issue for a while and you've been replicating data that whole time you've been troubleshooting, and you're like, you know what, screw it, we're just going to fail over into DR and we need to go back a little bit, we could do that. Error handling, we can stop on errors or ignore them. In this case, because it's a test, I want to stop on errors. And then it's going to show me the steps, right? So in this case, it's just going to recover 2 VMs, and then I'm going to be all set. And if I type test plan here, this is going to go ahead, and it's actually going to run my test plan. The difference between test plan and failover plan is that test plan does not fail the resources over from the primary site. So it just does the recovery at the DR site. It does the recovery and it does the power ons. And again, we can see over here, we've got recovered VMs now. Whereas a failover will actually shut down and clean up the prod site and then do the failover to the DR site. So again, if we look at that and the amount of time it took me to show you how to create a DR plan, what the DR plan was doing, and execute the DR plan, and then these VMs came up, it took less time to explain how to set up control shift than it did to actually do individual recoveries on these VMs. So again, as you're thinking about in your data center, right, if you've got 2-site DVX and you're replicating already, just think about maybe wanting to look at control shift if you're interested in doing DR. So with that, I'm gonna wrap this up for today, and I'm gonna kick over to the chat and start answering your questions. But again, the other thing to just keep in mind is that I used control shift here to do this because this is our product, and I want to show you everything that's kind of in our stack. We also do have an SRA plugin, and I'm going to do a couple advanced recovery trainings. So it'll be probably next week and the week after. We're going to get into more advanced recovery of both disaster recovery as well as doing like SQL recovery and things like that. And I'll show you what DVX with SRM looks like utilizing the SRA plugin. Okay, so in chat, so can it be, so replication encryption, can it be enabled after the fact? Yeah, replication encryption can be enabled after the fact. The only thing that replication encryption is handling is the TLS connection between the sites. So if you enable it after the fact, it's not like enabling VM encryption after the fact. So if you do the data store encryption after you enable, or I'm sorry, if you do data store encryption after you've put data on the data node, we want you to move all the data out and then back in so that we can ensure that every block is encrypted. The site-to-site replication, you can enable that at any time, and it's not gonna hurt anything. And then it does not require the PGs to re-replicate from scratch. Jonathan, thank you for the suggestion. I will talk to you more about that. And then as far as Jay, what about the VMware Power CLI or Dell Power CLI? Definitely, there's a lot that we can do with Power CLI in terms of recovering snapshots and then automating the registration of the VM. And I would definitely recommend taking a look again at the documentation because we've got some examples in there of things we've done on the VMware side with, again, VRA, VRO, and Power CLI. So that should be good. So with that, unless anybody else has any questions or anything they want to bring up, thanks you guys for sitting through another week of this with me and dealing with the fact that I forgot to share the screen for the first 10 minutes. And yeah, we'll see you next week for talking about actual disaster recovery using Control Shift, and then do a little bit of DR using SRM as well.